day. This is Gary Mendoza, and my research title is Analysis of Aircraft Maintenance Error Inputs to Improve Safety and Quality. So, why did I choose this topic? I, researcher, is currently working as an aircraft mechanic at an approved maintenance organization. Based on my experience and observation, error committed before are still the same errors committed today. This is a proactive approach in aircraft maintenance errors. There are already a lot of international study regarding maintenance errors, but most of them focuses on human factors and investigation on maintenance error. In Philippine setting, there are limited number of research pertaining to aircraft maintenance. The goal regarding the analysis of aircraft maintenance error is to identify and manage them while they are manageable. Ideally, the researcher wants to recognize even those minor errors, including situations that backing them, so that it will not turn into error with grave consequences. The researcher analyzed the specific errors committed, including those unreported, based on the errors listed in maintenance error decision aid provided by the Boeing company. This research also provides a current set of data that the aviation industry can review and, if appropriate, use in improving their safety and quality. Aircraft maintenance processes are vital to aviation safety. The principal objective of maintaining an aircraft is to assure that it remains safe and flight ready throughout its service life. By any means, improper maintenance can contribute to a significant proportion of aviation mishaps. This kind of improper maintenance or errors can cause rework, downtime, and lost revenue to the airline. In this context, it can be seen that even simple errors such as unsecured panels or tools left inside the engine requiring a return to the gate and of course involve a significant cost. According to the Flight Safety Foundation, if an aircraft is damaged on the ramp, it will be unavailable approximately 3 to 4 days, subject to an average cost of 225,000 US dollars per aircraft. The airlines lose approximately billions of dollars per year referring to human error only, and this is too much for a simple error. It is important to note that errors tend to be invisible until they cause an aircraft return to ramp, or worse, cause property damage or injuries. However, most errors don't have any serious consequences. Either the error is minor, its effects are incidental, or is caught and corrected before it becomes a failure. Since those minor errors don't cause problems, it will be unreported and unidentified to all. It is easy to identify errors. We can just simply wait for some incidents or accidents to happen and adapt to the findings provided by the investigation. But the management does not want those things to happen. They should become proactive in this kind of situation because it will cost much the organization, or worse, may cost lives. This is how the research went. The organization need to control their aircraft maintenance errors so that the researcher may improve the safety and quality in their company. And in order to know which area to improve, we need to know which errors are mostly committed. The main statement of the problem is what is the level of frequency of aircraft maintenance errors. The researcher used mainly survey questionnaire in gathering data with 4-point Likert scale on frequency of aircraft maintenance errors to interpret the obtained values, with 4 for always is the highest and 1 for never is the lowest. And some errors will be scored never and always as predicted, and for the scores with often and always will be the areas for improvement. Statement of the problem also includes participants' profile in terms of job position, years of experience in aircraft maintenance sections, what are frequently encountered errors, Is there any significant difference when grouped according to job position? And lastly, what are the participants' suggestions and recommendations in order to improve the maintenance error? And to answer these questions, the researcher used different statistical tools such as percentage and frequency distribution, weighted mean, ranking, and Kruskal-Wallis age test. The researcher also used computerized statistical treatment on data gathered using Minitab 17 application. The hypothesis for the study is there is no significant difference on errors frequently encountered by the participants when grouped according to job position. Participants are profiled in terms of aircraft maintenance section, number of aircraft maintenance experience, and job position. First is the aircraft maintenance section. Participants from Aircraft Maintenance Division are divided into three sections based on the NAIA terminal, which the company caters their customer. From 135 participants, 36 or 26.7% from Terminal 1 caters foreign airline, and 27 or 20% from Terminal 3 handling other foreign and PAL Express operations. Majority of the participants belong to Terminal 2 or the MA12, which have 72 or 53.3%. This clearly indicates that more mechanics are deployed in this section to compensate the whole fleet of the major customer of the company in line maintenance operations. The second one is the job position of the participants. The result shows that majority of the participants who responded to the survey are Mechanic B and Mechanic A, which are the main productive personnel duly authorized to perform different maintenance. It is shown that Mechanic A had the highest number of respondents. This made this research more reliable because they were the one in supervisory position who have gained a lot of experiences in maintaining an aircraft. Thus, there is possibility or probability of more errors experienced or observed. And the last is the years of experience. Majority of the participants are above 1 year, but not more than 5 years, and above 5 years, but not more than 10 years. This shows direct relationship of participants' year of experience to job position. Junior mechanic have 0 to 1 year of experience, while Mechanic C and Mechanic B work as mechanic from 1 to 5 years. Mechanic A, before being authorized to release an aircraft, must have at least 5 years of aircraft maintenance experience in accordance to company and customer regulation. Maintenance error decision aid listed 8 different major maintenance error. These are errors in installation, servicing, repair, fault isolation check or inspection, foreign object debris or damage, airplane or equipment damage, personal injury, and maintenance control. To answer the statement problem number 2, based on the data gathered, errors are generally rare, experienced, or observed, and error in repair is the only never experienced. Based on the weighted mean result of respective variables, there are 5 errors referred to as often committed errors. Personal injury had its 2 errors recorded the highest overall mean compared to the rest. These are the hazardous substance exposure and hazardous thermal environment exposure, which tells us that mechanics are becoming more concerned to their personal health safety while working on complex system in the aircraft. The other 3 are debris on ramp, tools, equipment used improperly, and the scheduled tasks are omitted, incorrect, or late complied. Listed below are the often committed maintenance error with respective conclusion and recommendation. First, the foreign object damage debris with the conclusion of they are unable to properly clean due to limited grounding time and strong winds on ramp. The recommendation is to include FOD walk-around check in task card or check sheet prior RTS. Second is airplane equipment damage, which was due to improperly use because of unavailability and complexity of tools. The recommendation, of course, is to ensure availability of enough tools and training on complicated tools. Personal injury is to exposure of to heat and hazardous substance are naturally part of the job, and the best way for to recommend is to ensure availability of personal protective equipment. And last is the maintenance control error. These are not complied due to heavy workload and natural calamity. And the recommendation is efficient planning of workload versus manpower should have awareness or simulation of contingency plan regarding the natural calamities. Is there any significant difference on the errors when grouped according to job position? In summary, participants agreed that the aircraft maintenance error are rarely committed with overall weighted average mean of 2.112. Table also reveals that the junior mechanics have the lowest average weighted mean of 1.879, and the aircraft mechanic A most have the highest mean in different kind of errors. Previous studies about maintenance error shows that installation error ranks number 1 or the most frequent, but in this study it ranks number 7. Ranks number 1 is personal injury to be followed by foreign object debris or damage and the airplane equipment damage. To answer the statement of the problem, under Kruskal-Wallis H test using H stub with degree of freedom with 2 degrees of freedom of 5.99 and H-cal result of 10.79. Since the H-cal is higher than the H-stub tested at 0.05 level of significance, there is enough evidence to reject the null hypothesis. So, therefore, there is significant relationship to maintenance errors when grouped according to job position. For the last part, what are the suggestions and recommendations of the participants to minimize or control maintenance error to improve safety and quality? So the participants generally agreed that specific maintenance error training, in addition to human factors and aircraft type, should be considered part as of error reduction technique. And there should have a common manual for quality and safety for customer and company to avoid confusion. And soft skill training such as leadership, assertiveness, and decision making must also be given to mechanic A and B for safety and quality empowerment. And lastly, annual training of criminal and administrative liabilities of aircraft maintenance can also be considered part of the human factors training just to remind everyone their responsibilities. This is the end of the presentation. For any questions or clarifications, feel free to message me on my email, gary.mendoza12.gm@gmail.com. Thank you for listening and have a good day.